Hi, my name is Adam Carlson. I'm a member of the HPC team at Wake Forest University. Today, I will be talking to you about high-performance computing on Wake's DEAC Cluster and giving an example workflow. Let's begin with a quick overview. So what do I mean when I say high-performance computing? Well, HPC, or supercomputing as it's commonly called, is a collection of computer systems configured to work together in order to solve large, complex, and/or parallel problems. So when do you use HPC? Well, if you are trying to run a script or software and find that it takes too long to run or that you can't work on anything else while it's running, HPC could be a good solution for you. Or if you have to run the same script hundreds or perhaps thousands of times to gather all of the data that you need, HPC could also be a good fit for you. And lastly, if you want to be able to log out of your computer or not worry about reboots occurring while your script is running, HPC could definitely help you. If you find yourself falling under any of those categories, how can you go about using HPC at Wake? Well, you could use our cluster. It's called the Distributed Environment for Academic Computing, or DEAC for short. It was actually established in 2002 by the physics department. Over time, more departments started to use it, and eventually, the cluster became a centrally funded resource managed by information systems. This makes it a free resource to all Wake Forest Reynolda campus faculty and students, and the DEAC Cluster now supports 13 departments across the university. So what does a cluster look like? Here is a general overview of the DEAC Cluster architecture. It's broken down into three main components: user access on the left, support services in the middle, and compute nodes on the right. User access is through what are called head nodes. These are the only outward-facing systems on a cluster which a user can log into or transfer data in and out of the cluster. When logged into a head node, this is where users can submit their scripts or software to run as jobs on the cluster's compute resources. You'll also see archive storage shown, which is on the DEAC cluster, and it's a data storage environment located remotely in the cloud. Support services are vital to the cluster's operation and act as a gateway between the users and the cluster's compute resources. The DEAC cluster has dedicated research storage for its users. This storage is mounted by all cluster components, which is to say that it ensures a user's data, code, and required software are available everywhere a job may run. Support servers are hosts to functions that must be up and running for the cluster to operate. The best example of this is our Resource Manager server. The logo there is for our Resource Management Service, SLRM. The SLRM server communicates with a client installed on a cluster head node to allow user jobs to be submitted, and on cluster compute nodes to ensure those jobs are evenly and fairly distributed across all available resources. Without SLRM, there is essentially no cluster. And another lesser example of a support service would be our license server, which hosts licenses that must be checked out and back in for certain software to run within a user's job. Compute nodes are the horsepower within a cluster. They contain all of the consumable resources available to users, like CPU cores, memory, or GPUs. Users can request to run their jobs on these resources when they submit a script. The resources on the compute nodes are what SLRM keeps track of amongst all user jobs running. It's our goal to ensure these resources are always available and highly utilized. Having seen the architecture, let's break down some of the available resource numbers. The DEAC cluster is host to 108 compute nodes, which contain a total of 3,800 cores and 20 terabytes of memory for users to consume. In comparison, your average Wake Forest laptop will contain 2 cores and about 8 gigabytes of memory. So you could say it's similar to having 1,900 laptops at your fingertips, only these would be much faster and much more efficiently configured than any normal laptop. The shared storage mentioned earlier totals 180 terabytes. This is used to store active research results and datasets and is backed up weekly to the cloud. Those cloud backups should not be confused with our cloud archive, which has an unlimited capacity. So we ask that researchers move old or inactive data they wish to keep here to our archive. This keeps our higher tier storage available for researchers. Usage on the cluster, as mentioned earlier, is spread across 13 departments at Wake Forest. For each department, the HPC team installs and updates required software as needed. You've heard mentioned that jobs are submitted to Slurm, which is done via batch submissions. And every cluster system runs on the Red Hat Enterprise Linux operating system. Knowing now the high-level operations of the cluster, it's time to go over the basics of workflow on DEAC for job submission. For this presentation, we will be using R as the basis for our example. The steps we're going to go over are: 1. Log into the cluster. 2. We have to know how to use R locally or on the cluster. 3. We have to write our code. 4. We need to know how to transfer code and data to the cluster. 5. Then we'll develop a Slurm batch script for our R code. 6. We will review how to submit the batch script as a job. 7. We'll cover how to monitor your job. And 8. Lastly, we'll check our outputs. So let's dive in, shall we? As was mentioned, the DEAC cluster is only accessible through its head nodes. Currently, there are 2 head nodes to choose from: pegasus.deac.wfu.edu or gemini.deac.wfu.edu. Our head nodes are only accessible from campus networks to log in. So this means your computer on campus must be connected to the WFU wireless network or a wired direct connection. If off campus, your computer must be logged in to the Wake Forest VPN with your campus account. Outside of those options, you will not be able to connect, which is primarily for security reasons. To access the DEAC cluster, users will need to use the Secure Shell Protocol, or SSH for short. SSH is a communication protocol commonly used for terminal connections. This means it's normally used via the command line, or CLI for short. So if you're running on a Mac or Linux computer, you can use the built-in terminal of your operating system and simply type SSH, your username, at one of our head nodes, .deac.wfu.edu. Press enter and move on. From a Windows operating system, however, an application must be used. The application that the HPC team recommends is PuTTY. PuTTY is already installed on many Wake Forest computers, but it is very quick and easy to install yourself if not. Simply follow the link provided, download PuTTY, and double-click to load the executable. Since using PuTTY is a bit more cumbersome than using the terminal on a Mac or Linux, we're going to focus a bit more on PuTTY next. When you open PuTTY, it looks like the window shown here. If following along, pause the video now to ensure PuTTY has been downloaded and is up and running. To connect to the cluster with PuTTY, we'll first need to give a hostname. This should be either of the two head nodes mentioned, pegasus.deac.wfu.edu or gemini.deac.wfu.edu. Please remember, you will need to type the entire hostname to connect. Since you will be connecting to the DEAC cluster more than once, we recommend you create a saved session to connect more easily in the future. After you type the hostname, type a name in the Saved Sessions bar, click the Save button, and then once clicked, you should see the name appear in the list below with default settings. To use the saved session in the future, you've got to click the saved name, and then click the Open button. The view shown here will be the same for both PuTTY connections and Mac or Linux terminal connections. So at the login prompt, type your assigned cluster username and press Enter. Next, you will need to type your user password and press Enter. Take note that the cursor will not move while you type the password. This is just a security feature. If the next thing you see in your terminal is the DEAC cluster banner shown here, then congratulations, you have successfully logged in to the DEAC cluster. With a successful terminal connection now established, let's next look at how to use R. To use R on the DEAC cluster, you do not need to have it installed locally to your computer. And that's because the DEAC cluster already has it installed. The HPC team does recommend, however, that you have R installed locally for basic script writing. The same code you write locally, regardless of operating system, will run on the DEAC cluster on Mac, Linux, or Windows. If interested, follow either link provided to download and install R locally to your system. Additionally, RStudio is an available application that provides a nice and easy development environment for R. It can be downloaded and installed to your local system as well. Looking at the cluster's R installation, users must load it the same way as any other software installation on the DEAC cluster, with the use of an environment module. Environment modules are handy because they load configurations to your current login session to make it as if those software packages you wish to use were installed locally for your user account, when in reality all software, including R on the DEAC cluster, has been installed on our shared storage, which is how we easily make it available across all of our nodes. To load R's configuration, type module load R/3.5.0 and hit enter. Typing a capital R here is important because Linux is a case-sensitive operating system, so a lowercase r will not work. To confirm that R is now a valid command, type which capital R. You should see a path returned to the R installation somewhere in /deac/opt/R. There may be multiple versions of this software installed. To start it is a good idea to check the loaded version of the software, which should match what you typed with the environment module. To check the version, you'll type capital R dash dash version. Note there should be spaces before these dashes or any other dashes referenced on a command for the rest of this presentation. The returning text should show version 3.5.0, nicknamed Joy in Playing, was loaded. To use R, simply type a capital R and hit Enter. The R environment should be loaded after doing so. This can be confirmed by the angle bracket, or a greater than symbol, now visible as the cursor on the terminal. Moving on, let's get a quick sample R script going. So for this example, any text editor will do. Assuming a Windows system is being used, just use something simple and effective like Notepad. Open Notepad and type out your R code. Once done, save it as r-example.r. Here's a fully fleshed out, better look at our example code for this presentation. You may have received a copy of this code from your professor, but if not, you may want to pause the video to copy it down if need be. With our code now written, we've got to get it transferred over to the DEAC cluster next. To transfer files to the DEAC cluster, users will need to use Secure Copy, which uses SSH to securely copy files from one system to another. Much like SSH, it is a command commonly used on the command line. So once again, if you're on a Mac or Linux computer, you can use the built-in terminal to your operating system to use Secure Copy via command line. Simply type SCP followed by the path to your file or folder to copy, space, your username at one of our head nodes .deac.wfu.edu, colon, the path to your destination directory. From a Windows operating system, the HPC team recommends using WinSCP. WinSCP is a very simple program that can be downloaded from the provided link and executed immediately after. Mac users can also use an application called FileZilla, linked below. Once loaded, WinSCP looks like the window shown here. If following along, pause the video now to ensure WinSCP has been downloaded and is up and running. Let's go over some WinSCP steps. To connect to the cluster, enter one of the DEAC cluster head nodes as the host name. Again, that's either pegasus.deac.wfu.edu or gemini.deac.wfu.edu. Same as with PuTTY, you need to type the entire host name to connect. You'll also need to provide your cluster username and cluster password. Click the Save button if you wish to easily connect in the future. It should appear under your stored sessions, shown in the left pane. Please keep in mind, though, that if you wish to save this session with your username and password entered, other users may be able to log in as you if you leave your system unattended and unlocked. Then click the Login button. Once connected, the window will look like this, with two main divided panes. The section on the left represents your local files, and the section on the right represents your cluster files. From here, you will want to navigate to your research directory by clicking the drop-down menu from the bar above the right pane. Your path should be /deac/business/analytics and year, followed by your username. Once your folder is selected, we recommend you always try to organize your research scripts and projects with a dedicated subfolder. To do this, right-click in the right pane. In the sub-window, select New, then Directory. In the pop-up window, name your folder something. Let's try Example R. Then click OK. WinSCP can be used to move data to or from the DEAC cluster. To move data to the cluster, click your local files in the left pane and drag them to the right. To move data from the cluster, click your cluster files in the right pane and drag them to the left. Start by moving the example R file we wrote previously. Once successfully moved, next try the example CSV file, which should have been provided by your professor. If not, please pause the video now. If WinSCP asks you to overwrite files, you must provide an answer in order to proceed. In general, the HPC team recommends you do not answer yes to all unless you really know your files. The status window will disappear once all of your transfers have completed. From your terminal login session from earlier, you can confirm your files successfully transferred by changing directories to your research path with the command cd space, then the full directory path you selected with WinSCP, which should be /deac/business/analytics in the year /username/example R. Once in the directory, list all content of the directory with the command ls. Your files should be listed in the directory path output. Moving on to job submission next, now is a good point to pause the video if you're following along and need to catch up on any steps slightly behind. Moving on to job submission. Once again, we are going to be writing a Slurm batch script here. So for this example, any text editor will do. Most easily, this Slurm script could be written directly on the cluster. But again, we're assuming a Windows system is being used. We'll go back to Notepad again for this example. Open Notepad and type out your Slurm script. Once done, save it as example.slurm. Here is a fully fleshed out, better look at our example Slurm script. From this example, you're going to need to replace job name with something else of your choosing that easily identifies what type of job you're submitting. Replace your email with your actual email address on the mail user line. Replace the directory path to the path where your files are being transferred. And you may have received a copy of this script from your professor, but if you did not, again, you may want to pause the video to either copy this down or update it if need be. For more detailed information on the content of Slurm batch scripts, their directives, and how they work, check out some of our other videos on our YouTube channel, linked below. Once your script is written, transfer it to the cluster if written locally. Again, either use WinSCP as covered previously, or use SCP via the command line. With our R code and Slurm script both transferred to the cluster, it's time to submit our script to the cluster as a job. To do this, you will need an active SSH login session to the cluster head nodes, which you should still have up from earlier. Submitting jobs to the cluster is done with a single command. From your terminal session on the head node, ensure your current directory is the same as where you transferred your data, preferably into that example R directory. This can be confirmed once again with the ls command, where you should see the R code, Slurm script, and that sample data listed. If present, the job can be submitted by typing sbatch example.slurm. If successful, the result will return a unique job ID. If an error is returned, though, check to ensure syntax and case are correct first. That's both within your Slurm script and on your command submission. Next, check to ensure the referenced R file within the Slurm script is correct. If still unsure, always feel free to ask the HPC team for help. When a job has successfully been submitted, it can then be monitored. From the session where the job was submitted, 2 commands can be used to look at your job's progress. The first is the SQ command, which shows all the jobs running or waiting to run on the DEAC cluster. To look specifically at your job submissions, type SQUEUE, which is SQ, -U, and then your username. If the job appears in the pending state, represented by a capital PD in the 5th column of output, the same command can be run again, but also with the --start option. That option will show the expected start time of your job, if relatively soon, within the next 24 hours. The other command is SACCT, pronounced as S account, -U and your username. This shows a list of all recent jobs your username has either had run, been in a pending state, or completed on the cluster. Once your job is finished running, it will no longer appear in the results of SQ, but it will show in the output of the saccount command, and the status will show as completed. Those results will be phased out over time, so it won't always show all of the jobs you've had completed on the cluster. You should also have received an email thanks to the mail type directive in our Slurm script. Here is an example of a beginning email, which is sent when a job starts, along with the location of a job output file and running node where the job is located within the email content. Here's an example of a completion email, which is sent when the job completes and contains a summary of used resources, time run, etc. Once you've received that completion email, your job is completed, so it's time to check our outputs. From your login session, where the job was submitted, if you use the command ls, you should now see 3 additional files. These files are outputs from your job. The script generated both error and output files, and the R script generated output. If the output file is not present or contains unexpected output, then there is most likely a typo within your R script. Check syntax or the name and location of your CSV file. The content of your output file should look something like shown here. It can be transferred to your local machine with the process we discussed earlier, using WinSCP. If your output looks good, then consider your job successfully submitted. Congratulations. That concludes our presentation about the DEAC cluster at Wake Forest University and our example workflow with an R script. Hopefully you found the content of this video helpful. If you need clarification or have follow-up questions or comments, please contact the HPC team directly at deac-help@wfu.edu. Be sure to check out our other resources for users, including our website, user wiki, YouTube page, or even follow us on Twitter. Thank you and have a